Aerial robots have become ubiquitous in the last decade, driving the need for hands-on aerial robotics courses to train the next generation of engineers. But conducting such a course is arduous. Building realistic arenas takes time, and frequent crashes lead to constant repairs. We introduce VizFlyt, an open-source perception-centric hardware-in-the-loop testing framework where a physical robot flies in an empty space equipped with an external localization system. By combining with 3D Gaussian Splatting to hallucinate visual sensors, users can safely test their drone autonomy algorithms. Our framework uses images captured from a handheld camera to train a high-fidelity digital twin using 3D Gaussian splatting. To showcase the efficacy of VizFlyt, we carry out several real-world experiments commonly found in aerial robotics courses. We navigate through windows in a setup inspired by drone racing competitions. Our method segments the windows and calculates their 3D locations to enable relative waypoint navigation. To fly through unknown gaps, we estimate optical flow to identify navigable areas and use image-based visual servoing to align and navigate the drone through the gap. Our framework also enables hallucination of dynamic obstacles. For example, in this case we use image-to-image homography to simulate a dynamic clock hand. Our framework automatically grades assignments by detecting collisions within a 3D occupancy grid map, ensuring accurate evaluation of obstacle avoidance performance. With an impressive update rate of 100 Hz, we push the limits of VizFlyt, testing high-speed obstacle avoidance and reaching maximum speeds of over 5 meters per second. Our framework will be pivotal in future research by enabling navigation in adverse conditions, testing different optics, and generation of embodied agent datasets. Thank you for listening. Our course, including the software and hardware workflow, will be completely open source, making it future-proof for upcoming aerial robotics courses.